To understand the PN junction diode, let us quickly revisit the semiconductor basics. Consider an atom with nucleus and electrons. Nucleus consists of protons and neutrons. Protons have positive charge while neutrons have no charge. Hence, nucleus has positive charge. Electrons have negative charge. If the protons and electrons are equal, then effectively the atom is charge neutral. In general, the atom is neutral under steady state conditions without any external excitation. Think of atom as a building block to build larger systems. These are the building blocks. Think of atom as these building blocks where you build a larger system. Atoms are building blocks for forming elements in a periodic table that we would have studied in our chemistry class. Let us consider a subdivision of those elements and we call it as material types. Consider three different material types: conductor, insulator, and semiconductor. All these materials are basically larger systems formed by the building blocks which are atoms. Example, a conductor like copper is formed from copper atoms. How do we know that a particular material is a conductor? Take a charged material. Let us say this has negative charge. Now bring this charged material and touch the conductor material. Let's say this is the conductor material. Now bring this charged material closer to the conductor and immediately the electrons within the conductor they start moving rapidly and away from the negatively charged material because like forces repel. But eventually they will all settle down to a steady state. This introduces another charge called as holes. When the electrons from the atom are pushed out due to external excitation from a charged material, a void or empty space is created in the atom where previously an electron existed. These empty spaces or void are called as holes, and now the atom is no longer neutral as negative charge is less than positive charge, and hence making these atoms as positive ions. Thus, holes are waiting for electrons to fill the empty space and are considered as positive charges. Coming back to our conductor, as the charges have high mobility, they are very eager to move around with external excitation. Next, consider an insulator. With same experiment as before, it is observed that the charges do not move around as freely or move very slowly in an insulator because charges in insulator have low mobility. So, in an insulator, charges have low mobility. Remember, movement of charges is electric current. And we want to control this flow of current. If we use conductors and insulators, we either have continuous current or no current. We need a material which is something in between. Conductor gives continuous current. Insulator no current. Enter semiconductor. As the name suggests, it has the property of a conductor where charges can move freely but with limited mobility. This mobility can be increased by adding atoms from another element which now reacts with this original or intrinsic semiconductor to form an extrinsic semiconductor. This is an intrinsic semiconductor. Now add impurity atoms. From another element This is called as dopant. Together it forms an extrinsic semiconductor. Intrinsic semiconductor is charge neutral, but the extrinsic semiconductor is no longer charge neutral and is either positively charged or negatively charged. The added material is called dopant and the process is called doping. The resulting new material is either a P or N material based on the dopant charge. If the dopant has excess electrons negatively charged, then the semiconductor material will have excess electrons and is likewise negatively charged and called N-type semiconductor. If the dopant has excess holes or lack of electrons positively charged, then the semiconductor material will have excess holes and is likewise positively charged and called P-type semiconductor. Combining these two materials gives us a PN junction diode. P-type material has all positive charges in excess, while N-type material has negative charges in excess. And this is a PN junction diode. In the next session, let us understand the PN junction diode.